Okay, let's jump right in. Have you ever wondered how apps like YouTube, Instagram, or Netflix can stream crystal clear video to millions of people at the exact same time without completely crashing? Today, we're putting on our senior system architect hats. We're going to completely demystify the massive, complex systems running behind the scenes of these massive platforms. And the best part? We're not just talking theory here. By the end of this explainer, you'll have a literal step-by-step blueprint to build a highly scalable video platform yourself. Look, if you're a college student or a beginner in backend engineering, building a system like this is hands down one of the absolute best things you can do to make your tech resume stand out. So let's get into it. To really appreciate this, we have to talk about the sheer scale of the problem. Over 1 billion hours of video are watched daily on YouTube. And get this, an astonishing 500 hours of new video are uploaded every single minute. Every single minute. Take a second to just process that. If you tried to handle that kind of traffic using basic web dev tricks, your servers would literally melt in seconds. As engineers, our whole job is designing systems that handle this data gracefully. Understanding how to juggle massive files and concurrent users, that's the exact bridge you need to cross to go from a junior coder to a true system architect. So here's our game plan for this explainer. We'll start with 1, the big picture architecture, move into 2, data storage and databases, and then cover 3, APIs and core algorithms. After that, we'll dive into 4, video processing and streaming, map it all out with 5, the 4-week build plan, and wrap up with 6, boosting your tech resume. We're going from high-level design straight down to the exact bullet points for your next interview. All right, let's kick things off with section 1, the big picture architecture. To really grasp system design, you've got to separate what the user sees from the machinery doing the actual heavy lifting. On one side, you have the front end. This is your React code, the slick video player, the buttons, basically the face of the app. But the real magic? That's all happening on the back end and in the cloud. This is where your Node.js or Python scripts run, where databases live, and where cloud storage safely holds those massive video files. The front end just politely asks for data. The back end does the incredibly hard work of actually finding it and delivering it safely. And this brings us to how modern engineering actually works. It's all about microservices. When you build your first app, you probably just shove all your code into one giant file, right? But platforms like Netflix and YouTube, no way. They break everything down. You have one independent service just for user logins, another just for converting video formats, and a completely separate one for the recommendation feed. Why? Because if the video processing service randomly crashes due to a bug, your users can still log in and watch videos because the authentication and feed services are completely separate. It's kind of like watertight compartments on a ship. Moving right along to section 2, data storage and databases. This brings up a super critical question. If databases are so amazing, why don't we just stuff a giant 10 gigabyte video file right into a standard SQL database table? Well, please don't do that. It's a terrible idea and it will completely destroy your performance. Instead, the industry standard is to use blob storage or object storage, like AWS S3. Think of blob storage as this massive, infinite hard drive in the cloud. It doesn't care about neat columns or rows. It just takes your massive, unstructured raw video files, stores them efficiently, and hands you back a simple URL to access them. So then, where do we use a structured database like PostgreSQL? For basically everything else. Check out this table structure. We've got models for users, videos, and interactions. But notice the video model. We aren't storing the video there. We just store the S3 URL. It's just a pointer to our blob storage. Using an ORM, an object relational mapper like Prisma, we can easily link a user's ID directly to that video or track interactions, like figuring out exactly who liked what video. But here's the catch. What happens when your app blows up and you suddenly have 2 billion users? A standard Postgres database on a single server is literally going to melt under that pressure. As an architect, you need to know about clustering. YouTube actually scales its massive MySQL databases using a technology called Vitess. It takes a giant database and shards it, meaning it horizontally slices the data across thousands of smaller servers so no single machine gets overwhelmed. You'll probably just use standard Postgres for your personal project, but dropping a term like Vitess in an interview, that is a massive flex. Okay, on to section 3, APIs and core algorithms. How do our front-end and back-end actually talk to each other? They talk through REST APIs. Here are the core endpoints you'd realistically build. You've got post requests for registering users and get requests for fetching the home feed. But I want you to pay very close attention to that /videos/pre-signed URL endpoint. This is a total senior level pattern. Instead of a user uploading a massive 5 GB video directly to your backend, which would completely clog your network, your backend generates a secure pre-signed URL. This acts like a VIP pass, giving the user's browser temporary permission to upload that massive file directly to S3. It completely bypasses your backend servers. It's brilliant. And you know those data structures and algorithms classes that feel super theoretical? Well, this is where they actually become your best friend. They literally power these API features. Arrays are perfectly designed to manage sequential watch history. Hash maps, they give you lightning-fast O1 lookups for user profiles. Sorting algorithms rank that home feed. And graphs, they map the insanely complex relationships between users and videos so machine learning models can figure out exactly what you want to watch next. It's not just whiteboard theory, guys. It is the engine of the app. All right, Section 4. Video processing and streaming. This is arguably the coolest part of the whole system. What actually happens after that raw MP4 file is uploaded? It sets off a continuous automated pipeline. Think of it like a factory. First, the upload happens via that pre-signed URL we talked about, but we never, ever serve that raw file directly to the next viewer. It's way too huge. Instead, step 2 is transcoding. We use an awesome open source tool called FFmpeg to compress the video into multiple resolutions, 1080p, 720p, 480p. Step 3 is the real secret sauce. FFmpeg chops those videos into tiny 2 to 6 second segments. And finally, we distribute those tiny chunks across the globe. Chopping the video into those tiny chunks is what makes modern streaming possible, using protocols like HLS and Dash. HLS was created by Apple, while Dash is the open source alternative. Both use text files called manifests to basically tell the video player, hey, here's where the next 2 seconds of video live. And because the video is chunked, it enables adaptive bitrate streaming. Have you ever noticed how when your Wi-Fi suddenly acts up, a YouTube video doesn't just stop to buffer, it just gets a little blurry? That's the player seamlessly grabbing a 480p chunk instead of the 1080p chunk for the next 2 seconds. It's seamless. But how do those chunks get to your phone so fast? Through a CDN or content delivery network. Think of it like a local pizza delivery hub. If your pizza's baked in New York, but you live in London, delivery is going to take forever, right? But if a franchise hub opens right down your street, you get it hot and fast. A CDN caches or temporarily stores these video chunks on servers all over the world. This is exactly how YouTube achieves zero buffering, whether you're sitting in Tokyo, Paris, or New York. Okay, Section 5, the 4-week build plan. System design can feel like a lot, but I promise you can build this. Here is a highly realistic timeline to build this from scratch in just a month. Week 1, you lay the foundation. Get your Node.js backend running, set up that Postgres schema, and lock down user logins with JWT authentication. Week 2 is all about the cloud. Figure out AWS S3 and write the logic for those pre-signed URLs. Week 3, we get into the heavy lifting. Run FFmpeg for transcoding and wire up your APIs for likes and comments. And finally, week 4 brings it all together. Connect your React front end and write a clean sorting algorithm for the home feed. Take it one layer at a time, and it's totally achievable. And finally, Section 6, boosting your tech resume. You've built this incredible system. How do you actually talk about it so a hiring manager gives you the job? Look at the action verbs you can use now. Instead of saying, I built a website, you get to say things like, architected a video streaming backend, implemented secure direct-to-cloud file uploads, engineered an automated transcoding pipeline. Guys, these bullet points are absolute gold. They instantly signal to an interviewer that you understand distributed systems, cloud patterns, and async processing. That is exactly the language of senior engineering. And remember this real-world golden rule. Serving videos straight from S3 is a fantastic way to go bankrupt from massive AWS bandwidth bills. Always use a CDN and adaptive bitrate. In an interview, it's never just about what you coded. It's about explaining why you did it. Explaining that you used a CDN to slash cloud costs and guarantee low latency shows real product awareness. That why is exactly what separates an amateur from a future system architect. So there you have it. You now possess the exact blueprint for a massive distributed video platform. You understand how the front end talks to the back end, why we chop videos into chunks, and how CDNs deliver them globally at lightning speed. So here's my challenge to you. Open up your code editor today and just start building. Maybe use these exact principles to build a Netflix clone or an Instagram Reels app next. The knowledge is officially yours. Thanks so much for joining me on this explainer. Get out there and happy coding.